Lesson 17. Solve problems with inequalities. Let's look at the lesson objectives. Content objectives. Students will be able to write and solve real-life inequalities that lead to the form p times x, px plus q is less than r, or p times x, px plus q is greater than r, where p, q, and r are integers, fractions, or decimals. Students will be able to graph and interpret the solution set of an inequality. Language objectives. I can read to understand why the inequality symbol is reversed when each side of an inequality is multiplied or divided by a negative number. I can discuss and describe in writing how to solve and graph two-step inequalities using the terms inequality, constant, coefficient, and solution set. I can articulate the significance of open and closed circles, solid line segments, and arrows or number lines that represent solution sets. I can discuss with a partner or small group real-world situations that could be represented by given inequalities. I can interpret models such as tables and graphs to gather data needed to solve word problems. Let's look at the prerequisite skills. Compute with rational numbers to solve equations. Write, solve, and graph inequalities. Lesson vocabulary. There is no new vocabulary, but let's review the following key terms that are important for this lesson. Inequality. Two unequal values that are compared using less than and greater than symbols. Solution set. A group of possible values that make an equation or inequality true. Determine. Decide based on evidence. Reverse. Change something to its opposite. Suppose. To think or imagine something is true. Learning progression. In grade 6, students studied inequalities with infinitely many solutions and represented the solutions on a number line. Earlier in grade 7, students solved real-world problems using equations. In this lesson, students expand upon what they learned in grade 6 about inequalities. They solve real-world problems using inequalities and graph solutions on a number line. In grade 8, students will solve real-world and mathematical problems leading to systems of equations. Let's use what you know. You've learned how to solve two-step equations. Let's take a look at this problem. Mr. Thomas brings $100 to a fundraiser. He wants to leave the event with at least $50 in his pocket. Guests at the fundraiser buy raffle tickets for several different prizes. Each raffle ticket costs $2.50. How many raffle tickets can Mr. Thomas buy and still leave with at least $50 in his pocket? These 7 questions here are going to help you answer that question. Use math you already know to solve the problem. Question A. How much money does Mr. Thomas have at the start of the fundraiser? Read the description or the question carefully, and all the information is there. Question B. Let T equal the number of tickets bought. Write an expression to show how much it costs to buy T tickets. Question C. Use the expression above to write a different expression that shows how much money Mr. Thomas would have left after buying T tickets. Question D. Suppose Mr. Thomas buys 25 tickets. How much money would he have left? Is this at least $50? Show your work. Question E. Suppose Mr. Thomas buys 20 tickets. How much money would he have left? Is this at least $50? What is the greatest number of tickets Mr. Thomas can buy and still have at least $50 left? Please explain. Question G. Could Mr. Thomas buy fewer than 20 tickets? Explain. And the last question H. Fill in the blank. Mr. Thomas could buy any number of tickets that is blank or fewer. So pause this video. See if you can solve all of them or any of them. When you unpause, we will go through all of them one by one so you can understand them and hopefully match your answers. Alright, question A. Hopefully you got $100. That information was given, right? Question B. Write an expression to show how much it costs to buy a ticket. You would do 2.5t. If you got 2.50t, it's also the same value. So 2.5 means basically $2.50 per ticket. It says it here. Each raffle ticket costs $2.50. Question C. Think about this. Mr. Thomas would have left. How much money would Mr. Thomas would have left after buying T tickets? Well, if he has $100, you subtract $2.50 per ticket. So this is how you would write the expression, right? Because every ticket is $2.50. So if you bought one ticket, think about that. That's $100 minus $2.50. Because 1 times 2.5 or $2.50 is $2.50. If you bought 2 tickets, that means it would be $5. 2.5 times 2 is 5. Therefore, he would have $95 left. Let's look at question D. How much money would he have left if he buys 25 tickets? So what do you think you would do with this 25? Correct. You would plug it in to the variable t. And then you would do 25 times 2.5 and then solve this. Okay, when you solve it, there it is. Let me put this away for a sec. As you can see, there it is. They did 2.5 times 25. And that would equal $62.50. The reason there's a subtraction, right? He started with $100. If he bought 25 tickets, that's $62.50. 100 minus $62.50 will give you $37 or 37.5, which is $37.50. So that is less than $50. Think about that. Okay, is this at least 50? No. Question E. Let's see what we got here. If you got, again, if Mr. Thomas was to buy 20 tickets, you do the same thing with this expression. You plug it in for T, right? For T. And then you do $2.50, or 2.5 times 20, which will give you 50. 100 minus $50 or 50 will give you 50 or $50. Okay, is this at least $50? Yes, it is. So I want you to think about that carefully. We'll come back to that in a sec. Now let's look at question F. What is the greatest number of tickets Mr. Thomas can buy and still have at least $50 left? So let's go back here. Think about that. He can buy 20 tickets and he would have $50, right? So let's look at what they wrote. If he buys 21 tickets, he has less than 50. If he buys 20 tickets, he has exactly 50. The greatest number of tickets he can buy is 20. Okay? Notice what they did. They didn't just look at 20 and they say, oh, it's 50. They also tried it out with 21. I would also try it out with 19 just in case to make sure we get that. Okay? Question G. Could Mr. Thomas buy fewer than 20 tickets? And the answer is, of course, yes. Okay? Any number of tickets less than 20 would cost less than $50. So that would mean he would have more than $50 left. And what I would do, you can create a table or you can actually try it out. So if it was 19 tickets, how much money would he have left? Right? If If you bought 19 tickets, if you bought 18 tickets. Try those out and you'd see that that would work. Question H. Fill in the blank. Mr. Thompson could buy any number of tickets that is $20 or fewer. Hopefully, all this makes sense. If it doesn't, I'd go back to the beginning of this question and read it again carefully. Let's find out more. You can solve this problem on the previous page by writing and solving an inequality. And we're going to break this down right now. Okay. Starting amount. We know he started with $100. Ticket price. We're going to subtract it because every time he buys a ticket, he loses from the $100. So the ticket price, $2.5, $2.50, times the number of tickets he bought, right? Now, this is at least. Think about it. Is at least. Alright, it's not just less than or greater than, it's at least. So, this amount has to be greater than or equal to, because you can still have it equal 50. That's why it says it's at least. That's huge understanding. Okay, so the amount left is 50. Now, let's solve this. The way you solve inequalities, for those who remember, it's the same way you solve equations, except you have the inequality symbol. Solving a two-step inequality is similar to solving a two-step equation. But when you multiply or divide each side of the inequality by a negative number, you reverse the inequality symbol. I'll break that down for you right here in a sec, but let's look at this here, and then I'll break it down here. 100 minus 2.5t is greater than or equal to 50. Remember, it has to be 50 or greater than, right? 100 minus 100. The reason they subtracted 100 first, it's because you want to get rid of the constant. You want to get the variable by itself. The inverse of order of operations. We talked about that with equations. If you don't remember, go back to lesson 16 or previous lessons and you can see that. So anyways, 100 minus 100 is 0. Then you're left with negative 2.5t on this side. Whatever you do to one side of the equation, inequality, you're going to do the same thing to the other side. 50 minus 100 is negative 50. Now, since you are dividing here, first of all, it's negative 2.5 times t. The inverse of multiplication is division. Since you are dividing by a negative number, whenever you divide or multiply by a negative number, okay, this inequality reverse. Okay, you have to reverse the inequality. Alright, negative divided by negative is positive. 2.5 divided by 2.5, you're left with t. Again, whatever you do to the left side of the inequality, you have to do to the right side. Negative divided by negative is positive. 50 divided by 2.5 is 20. Okay, so that's why the answer is t has to be less than or equal to 20. Think about that. So t could be 19, it could be 18, it could be 20, right? Because it's less than or equal to. It can't be 19.5. For some problems, it would be, but not this case. You can't buy a half of a ticket. It can't be 19.6. Can't buy, a point of a ticket. Okay, let me break that down further with a flowchart so you guys can see that. Let's go back to here. So first we have the formula, which is, or the inequality I should say, 100 minus 2.5t, which is greater than or equal to 50, right? Because it's at least. Alright, what are we looking for? T. What happens to t first? Multiplied by negative 2.5. Remember, you always look to the left of the number or variable to see whether it's positive or negative. What happens to it after? Plus 100. Remember, look to the left of it. Since there's nothing there, it's plus 100. And then the output here is going to be 50. Notice I didn't put an equal sign here. That's with equation. Right now what I'm going to do here is put the inequality symbol. It says greater than or equal to. So I'm going to do that here. Greater than or equal to. And now let's backtrack to solve this. 50 minus 100. Right, that's what they did here. 50 minus 100, first step. You get negative 50. Now, watch this. negative 50 divided by negative 2.5. Whenever you divide or multiply by a negative, you change the inequality symbol. So now we have t is going to be less than or equal to. And negative divided by negative is positive. 50 divided by 2.5 is 20. So there it is. Okay? Same as that. So he can buy 20 tickets of fuel. He can buy 20 of fuel tickets. Let's use integer inequalities to examine why the symbol is reversed. A is negative 3 and B is 3. A is negative 3 and B is 3. Now you'll understand why we reverse. So A is less than B, right? A is less than B. On the number line, A is to the left of 0 and B is to the right. A is to the left, B is to the right. Now divide both A and B by negative 1. Think about that and compare the values. A becomes 3, right? Negative 3 divided by negative 1 becomes 3. And is 3. And B becomes negative 3. 3 divided by negative 1 is negative 3. Now A is greater than B. And A is to the right of 0 and B is to the left. If you're confused, try these out again. After dividing by a negative number, the quotient, the answer to a division, is on the opposite side of 0, which means the symbol is reversed. Hopefully this helps.